Here is Geometry, Unit 4, Quiz Number 2 review. We're going to be looking at our diagrams. We're going to tell which method that we can use to prove the triangle is congruent. Here we have a pair of sides the same. Here we have a right angle, so if you have right angle on one side, you have right angle on the other. Reflexive side. So we're going to prove these triangles congruent by side, angle, side. We could not use RHL. Yes, we have a right triangle, but we don't know the hypotenuse is congruent to each other. We have a leg the same. We also have another leg the same, but not the hypotenuse. In this case, we have parallel lines. Notice that if you have two arrows, your lines are parallel. So your transversal here would be the angles that are congruent. If we came this way, and we talked about these parallel lines and the transversal, we'd get that zigzag, which gives you those angles. So it matters what side you're looking at. And of course the reflexive side. So angle, side, angle would prove those two triangles congruent. How about the letter C? We see that we have one set of angles congruent. We have another set of angles congruent. Vertical angles would give us this third set congruent. But remember, AAA is not one of the ways we can prove triangles congruent. We can only use SSS, SAS, AAS, angle side angle, or RHL, right triangle hypotenuse leg. So none of these ways will prove the triangle is congruent. How about this one? We have a pair of angles the same. We have two sides the same. So it's starting to look like this is side-side angle. Two S's and the non-included side. But that's not one of our options. But if you look closely, this is a right angle. So the side opposite that is called the hypotenuse. And the sides that are perpendicular to each other would each be called a leg. So we have RHL, right triangle, hypotenuse leg. Next, we're going to tell whether you can if we can use the given information to determine if the two triangles are congruent. We're going to state our postulate or theorem, if so, or we'll explain why we can't. So let's go ahead and draw our possible triangles. We have ABC and we have DEF. Label it A with D, B with E, and C with F. Knowing that information, is there enough information to prove the triangle is congruent? Of course not. Can't prove triangles congruent with angle, angle, angle. Must have at least one side. This next set of information, we'll draw out our two triangles, and this time I'll put the letters in a little bit different order. Put our ABC this time, but D, F, and E there. So the A goes with the D, AC goes with the DF, and AB goes with the DE. So how are we going to prove these two triangles congruent? Side, angle, side. We have two S's with the included angle. Okay, here we're given some information. What other piece of information would need to be shown if we were going to use angle, angle, side? A, B, C, D, E, F. A is with D. AB is with DE. Now look what they're asking us to use. Angle, angle, side. So they've given us one pair of angles to match. Now I need to come up with another pair of angles. Which pair of angles would consider our side to be non-included, not in between the angles? Of course, angle C would have to be congruent to angle F. That would put the side on the outside of the two angles. Angle, angle, side. Two A's with the S not in between the A's. Here's our two diagrams, two triangles. We're going to complete the statements. Remember, congruent symbols use letters and equal symbols use numbers. So what would LX be congruent to? We could look here at the pictures, or we could just look straight up here in our congruent statement. LX is the last two letters. IW is the last two letters. Angle I is the middle letter, so angle L is also the middle letter. And we'll make an angle symbol just to make it clear that that's an angle. Angle A is the first letter, so angle G is the first letter. Those are congruent. Now, when we talk about equals, the equals means that we need to come up with numbers, so there's some calculations that are going to have to be done. W is supposed to match X. If X is 92, W is 92. 92 degrees. What's the length of IW? Well, IW is the last two letters. It should match LX. So if LX is 4, then I know IW is supposed to be 4. And then our congruent statement. There are 6 correct ways to write a congruent statement. They wrote their first congruent statement with ALX. Now we're going to write it with LAX. So I'm going to need to say triangle. The L goes with the I. The A goes with the G. And the X, of course, goes with the W. So that is another congruent statement that we can indicate what triangles are congruent with the correct orders. Corresponding parts are congruent. On our next page, we're going to be looking for the value of X. Now, look here at the congruent statement. We see that S is 2x minus 10. I just don't know which one of these it equals. So S is the middle letter. It has to match the middle letter. So in this case, it's going to be actually the third one. Didn't even consider that. So this is 2x minus 10. So I have 2x minus 10 plus 61 plus 63. All three angles have to add up to 180 degrees. This is 124. So minus the 10 from that, 114. Subtract the 114. And we're going to get 66. So x is going to have to be 33. X is not 33 degrees, it's just the number 33. In this case, if a point is on the perpendicular bisector, these two segments are the same length, and it's 90 degrees, meaning that they're perpendicular. If a point is on the perpendicular bisector, then it is equidistant. It's not called equal distant, it's equidistant to the endpoints. So any point here on this perpendicular bisector is going to be equidistant to the endpoints. So that's telling us that we're allowed to set these equal to each other. Minus the 4x, minus the 24, and x has to equal 3. Okay, now we have a few proofs to work through. AB and DE are congruent. They're already marked on our picture. Angle B and angle E are already marked on our picture. So what's the next piece of information? Do we have any parallel lines that give us angles that are congruent? Do we have any reflexive properties? Do we have any vertical angles? Aha, there it is. Vertical angles are congruent. So we're going to start out with our given information. Okay, here, I don't want to go too fast. We just noticed our given information. We also noticed the extra piece of information that we had to come up with on our own. So how is that going to help us prove the triangle's congruent? Remember, there's 5 ways to prove triangles congruent. 2 A's and the non-included side would be one of those. So I've talked about a side and an angle. I now need to talk about my vertical angles. And I had to use 3 letters because of the location of the vertex. If vertical angles, then congruent angles. Then we can finish up with what we're trying to prove. And that's going to be angle, angle, side. 2 A's and the S not in between those A's. Here we should look at which of these triangles are we trying to work with. Are we working with big ones? Are we working with small ones? The ones on top, the ones at the side? PTQ is the top angle, triangle. RTS. So we're working with these 2 triangles. We're not even looking at these outside lines. We know that T is the midpoint of both of those segments. So that's going to tell us that we have segments that are congruent. Now that's only 2 bits of information. Those are sides for our triangles up and down. We need to come up with another part of information. What do you see? Of course, you have the big X. So it's vertical angles. So we have this angle congruent with that one. Now we can see that the triangles are congruent with one of our 5 ways. That's called a plan. You looked at your given information, you marked it up in your triangle, you found additional information if needed, and then we're able to show the triangle's congruent. T is the midpoint of PR and SQ. If it's the midpoint, what does that mean? What did it do for us? It gave us that PT was congruent to RT. It also gave us that ST was congruent to QT. If midpoint, then what can we say? Then segments congruent. Okay, so that got us some S's. What else do we need to talk about? What did we come up with in our plan? We talked about angle PTQ being congruent to angle RTS. If vertical angles, then congruent angles. What's going to be your last statement? Triangle PTQ is congruent to triangle RTS. Side, angle, side. You have two S's with the A that's in between. On our last page, we have our right angles. So because we have right angles, we might be able to talk about how those angles are congruent to each other, or we might end up talking about how we have a right triangle in RHL. We have to see what other information it tells us. It also tells us that NT is congruent to HT. So what's the next piece of information that we're going to need to talk about? The reflexive side. Good job. So we know that angle N, angle H are right angles. That was our given. And now we're going to be able to talk about another piece of given. I'm looking at the number of lines that we have here. This will be the triangles. This will need to be the reflexive. This will need to be a right triangles. So we'll need to throw in the NT is congruent to HT, all in the beginning with it. I usually like to spread that out some, but because of the numbers, I'm going to cram them in there. So what does it mean to have right angles? What does that give us? Triangle NOT,